Hello, Vincent. Hello, Stefan.
Hey, good morning, guys.
I'll just give everybody about 5 minutes here. So, Stefan, where are you out of? Oh, hello, Alex. We're just going to give everybody a little time to join. Hello, Victor. There's Mr. White.
Hello, sorry, I had to get an update for Zoom.
Nice. We're giving everybody a couple minutes to join.
No worries.
Yep, I can see
You guys see the agenda? Okay. Oh, I got the date wrong. Oops. There we go. Got it right in that one. Yeah. All right, let's give them one more minute. Thanks everyone for joining. First off, is there anybody from the foundation on that wants to talk about any administrative topics? Can't see who's all on.
I don't see anyone, John.
Okay.
And I think you covered it there on that first topic. Looks good.
Yeah. Yeah. So I'll go ahead and cover my first point there. So calls for proposals is open for the 2024 Global Summit and Future Technologies Symposium. So that's going to be held October 15th through the 17th in San Jose. And the submission period is ending Friday, June 21st at 5. So if anybody's interested, and I encourage you all to contribute a submission, get it in by June 21st. So the next thing, and I kind of apologize. It's been kind of a crazy month here. They had the regional summit, so there's a lot of things going on, and then I was traveling the last 3 weeks, so I've been kind of out of pocket. And I normally try to send a reminder like on Thursday or Friday beforehand, and I just didn't get a chance to do it. But is there any topics that you guys want to bring up that you'd like to talk about today?
Nothing specific. I
Anybody
thought
have
I'd just
anything?
solid and listen in.
Okay. Yeah. So, and then new members. Is anybody on the call new? They want to introduce themselves. No. Okay. I guess this will be a quick call today then. How about Alex? Let's see. What is he saying? Oh, okay, so Alex is out of London. He works for a Telco PE fund. Well, good to have you, Alex. And I'd ask you kind of what your interest is, but I know you're kind of verbally challenged there. Okay, Victor, I see you have your hand up.
Yeah, I don't know if it's in scope or not. This is about telco edge hardware. Anything specific about edge AI hardware? For yeah, hardware.
That definitely fits our charter. And that's something that if people want to contribute, that's I think more than welcome.
Listen to
Greg,
one
you have any
talk.
thoughts?
I listened to one talk about using the CXL technology to make it possible to have, I guess, bigger memory
Yes.
footprint to do, because AI workload obviously need more memory. Using CXL, you can have a kind of composable memory on the edge, sort of making it possible to do AI workload on the edge. That's one I can think of. And anything else?
No, I think that's a great topic. So we can we'll add that to what we talk about. Anybody else? Okay, so we have, let me add Alex up here.
And hey, John, I would, on that second bullet
Yeah.
item on CXL, I would say composable servers, because the CXL can also be used for there's 3 different types of CXL. So the type 1 is basically a network interface, and type 2 is accelerator technologies. That would be a device that has DRAM, and so you could have coherent DRAM with an accelerator card, and then the type 3 is actually then the memory cards, and so those would be DRAM, obviously, on cards using CXL to communicate with them. And so taken together, those 3 types can make a composable server, so that you could have a tray of servers, a tray of memory, a tray of storage, and a tray of, say, network interfaces. And then the potential is there to be able to compose a server from those elements, and then to take them apart, and when they're done, actually, and recompose them into other methods. So I think that's really a great topic for Edge, and especially it's being used a lot because the accelerator type 2s sometimes are the ones that have the NVIDIA AI accelerators, or the AMD accelerators, or Intel, so forth.
Yeah, no, definitely a great idea, and you'll kind of see that we've also been kicking around this DCMHS idea to have kind of a composable componentry as well. So yeah, I think those two things sounds like they could actually play really nicely together. Any other topics you want to add?
Most of the hardware discussions within the open compute ecosystem is about data center. So should we also go into like resource constrained IoT domain hardware?
Absolutely. Yes. Yeah. So that's kind of we're kind of the telco and edge groups kind of fit right. It's kind of taking the standard sort of data center IT form factors and specifications and things, and looking at this through this ruggedized environment, that typically adds a whole additional set of constraints, in terms of space, power, cooling, all that. And I think what a lot of the people find interesting is that potentially a lot of the innovation that maybe happens in that environment kind of makes its way back into kind of the data center space, right? Because the data center space doesn't necessarily have those same kinds of constraints, but could definitely benefit from things that are designed to kind of be able to exist within those constraints.
One thing that
Yeah, it's a great topic.
One thing on the software side that's been hard for edge computing is just the definition of a type of edge computing. And for that, the RFEdge, Linux Foundation Edge, has done some work to do basically define what type of edge it is. I'm not sure you're aware, but I can post that link. So and then on the hardware side, maybe it can be done as well. For example, when we're talking about IoT device, is there, I mean, just the resource constrained devices alone, how to classify the different of edge devices? For example, the health edge devices for those devices, is that any different from industrial edge? When it comes to both the form factors, those different characteristics. How do you classify the edge hardware? I don't know, is there any discussion anywhere, or that should be a topic here as well?
Yeah, no, I think that could probably be a topic as well. Um, originally, we kind of started as kind of this subclassification under telco, but I think there's a lot of interest to take it into these other realms now. I think that's kind of what we're seeing in terms of people that are participating in the group. So yeah, let's go ahead and add that as well.
So let me understand, are these just items that we would like to maybe have topics for conversation during the during our messages, or the things that we'd like to hash out into maybe white paper or requirements documents, or those kinds of things as well? I mean, what are we talking about with these? Just talking about them, discussing them now, or are we thinking we would like to make some create some documents around these items?
Yeah, I guess my preference would be is that we start to drive some contributions in some of these areas around what we feel edge could be. I don't know what the rest of the group thinks about it.
I find people are more, at least myself, is more interested when we're actually having a deliverable. I think it's also kind of drive everybody, to think about it and also contribute. So maybe even if it's just a draft, I would say I just posted the white paper from RFEdge. which if you look at page number, let's see, it's pretty on the top, number 3, which it's one way to define what kind of edge are there. I think this is more public cloud centric way of defining edge computing. So maybe we can do similar things for hardware to, define, what kind of a problem are there and what kind of a different type of hardware are there to begin with.
Let me see if I can do this. There, can you guys see this white paper now?
Yeah, you can see if you scroll down to page 3. Yeah, there are all kinds of different way of defining edge in the file computing. There's just different kind of definitions. But if you go to scroll to next, I believe the next page right here. Yeah, this is basically right there. If you go up, this is really how edge computing is defined at least in the RF edge world. So, and then probably we can, based on this, if there's no better, alternative to say, hardware wise, what type of hardware problems are there in each individual box there, and then how to classify them even further into, basically what kind of problem are there statement and what kind of solution already exists and what need to be invented.
So are you kind of suggesting, could we take this as a baseline and start to drive what we would do in this edge working group into some of these other situations, perhaps, through developing some assets or whatever, kind of taking what the Linux Foundation has done and kind of augmenting it? Would that be kind of like what the proposal would be?
Yes, in a way, this diagram already defined the problem from the application/software perspective, right? So now open compute is about hardware. So how does, just basically define the landscape and maybe even roadmap for hardware.
Yeah, that's definitely, I would think that it's interesting. Like, how would you go about this, Victor? Would you kind of like pick one of these and kind of flesh it out?
Yeah, maybe starting from what open compute is already good at, already done a lot of work, right? So from all the way from a centralized data center, which is mostly it's basically public cloud data center mostly, and of course some organizations still have their own big data centers, and then to the regional edge. For telco, that means that's the remote edge locations, I would say it's like cell tower, data center close to cell tower, right? So for those existing cases, what hardware solution already exists that's good for edge computing. I mentioned earlier about CXL. What other technology can be used in those edge use cases? And then extend to or also mentioned earlier, constrained devices, smart devices, how to categorize them. Why they're different? Because for me, I don't know. Like for the one that's device put on a car versus one that put on me, what's the difference, right?
Would somebody want to take a stab at maybe putting some information together that we can share next month and kind of starts to pull that together? So I'm thinking, if somebody wants to just kind of take a first stab at this and maybe present it to the group, we can start to build some traction around it, and that could drive what we want to talk about for sort of different edge use cases. Does anybody have any thoughts on that?
At least I'm not a hardware person, so otherwise I would love to do something myself. But what I think what can be done is, I believe it's we can probably just create based on the charter, create some even just a presentation about what the charter is, and then I come back and maybe reference this. This is happening in the edge, in on our fetch site, like on the, and then
So Victor, would you be able to put together some requirements from, say, a software perspective of what hardware may be necessary? Like, would you need, each of these areas may need, say, timing or a certain memory footprint or CPU capability, battery power, or just power draw in general, so the IoT is going to have much less power. How often does it process data? How does it connect? Those kinds of things. The edge device, smart edge, how would that differ from those, so that, even if we had like requirements from a software standpoint, it would drive a lot of details then on maybe hardware profiles for each of these different types. We have to start somewhere with say a use case, and then work from there for maybe each of these types of hardware. And then obviously we would want to then try to make some taxonomy of hardware, like where you could get reuse, some modularity between each of these elements as it, goes down essentially from the left to the, from the right to the left. I mean, they've got some of these characteristics there, the distributed, the latency critical, embedded software, right? I think each of those items are going to drive some types of, OCP-ish hardware kinds of requirements.
actually this
Yeah,
diagram.
like I don't think whoever put this together needs to get everything right. It's just maybe we have a framework, and
Yeah,
we can
well,
just
I think
have a
it'd be a living
collaborative session
document
where
for the
people.
work group. Yeah, it doesn't have to be right the first time necessarily, right? It's just something that to give some clarification to the work group, so what the project would talk about, or how we would approach certain items, or request even from other groups. Maybe the server group may be the place where we would have some requirements upward for some different types of hardware capabilities of this open hardware.
Sure, I can definitely work on that. But how do we communicate them? I mean, there's several ways to do this. One way we can just do it right here, right now, because what this picture on screen already have a lot of that information. Or we can, I mean, how do we, like, are you on Slack? Usually, I usually like Slack where we do it asynchronously. But I'm not sure.
Well, so yeah, so basically, the OCP has document repositories and a certain style for the document. So they're document templates, the OCP templates. So you may want to reference this as, say, a reference in an OCP document, but then you may want to, you want to phrase it in terms of OCP types of technologies, right? We don't want to reinvent the wheel necessarily, but we would like to incorporate those ideas and then to expand on them for the open compute community that maybe have never been involved with Linux Foundation, for instance. They may, that may be something where they're always working on PCIe interfaces or the CXL or memory interfaces, those kinds of things. They wouldn't have an understanding necessarily of what we were talking about when we were referring to like an edge device. In this case, say a smart device on the edge, right? And we're wanting some, a very small appliance. And so, they may be working on data centers stuff in the server area, but we need their expertise and help but we need to have some use cases to be able to describe, what those components are, right? Does that make sense?
Yeah, let me put definitely. I mean, I know some of it, so I can pitch in where I can. But what I can do is to, I mean, because I don't also speak I don't speak the language of hardware either.
Yes.
Maybe when you say define the requirement for hardware, is there any documentation on, when you have a hardware requirement, what kind of question do you ask from the from the app or the
Well, so we're basically talking. So there are OCP templates for document, okay, but I think what would come out of this would be a way for us to be able to ask other groups to be able to explain to the server group why the edge group would need a certain type of hardware. We typically don't have deep hardware expertise. Other groups, the network group would make a switch, but they would need to understand, oh, well, that switch needs to have some timing requirements. This is a typical telco thing, right? It needs to be NEBS compliant, needs to have some timing requirements, those kinds of things that they wouldn't normally put in, say, a data center switch. But somehow we have to document that, not necessarily in a hard requirements document that they must respond to or something, but more in an informational way, so that when we have people from other groups in the OCP that we're wanting to use their technology or to have them, say, modify the technology slightly, they would have a frame of reference to discuss that with us.
Yeah, I'm thinking. I don't know if you guys can see what I'm doing here, but I'm kind of
that's good.
Kind of just starting to throw it together, right? And we could start to just kind of profile these things.
And Victor, we would really love to have these kinds of things kicked around on the mail list, right? So someone could propose a draft, and then the other folks could put in other area, sections and stuff. So basically, we're kind of looking for someone who's interested in it to act more as an editor, if you will, than actually necessarily having to author the whole thing, right? And we'll obviously help with the OCP foundation, the templates, and to make sure that the process is followed and those kinds of things. Does that make sense?
Yeah, it makes sense. Yeah, I also, what you mentioned earlier about I know there's also a timing protocol thing. Yeah, I agree that's all need to be spelled out about hardware requirement.
Right. And it doesn't have to be, down to like the chip level or the component level, right? We can leave that to the experts, essentially, right? We're just needing to how do we need to describe that to them in a way that they can understand, what we're looking for. Obviously we can drive our own hardware as well, which we've done. This working group is actually about hardware definition for originally started as an edge compute server and chassis platform, right? And it's kind of evolved into more broadly edge devices as the edge has become an important, seen as a more important topic than just, the base of a cell phone tower being the edge, right?
Yeah, I would say like we've primarily done this case here. Would you agree, Craig? And what we're talking about is these other things here could be completely new avenues to explore.
Right. Yeah, absolutely.
Right. I mean, because we kind of focused on this.
Yeah.
Nobody's really looked at these. So like people don't even know what to talk about for these things. And I think Victor, you're making a great suggestion here. Maybe we just kind of throw this out as a straw man, and this gives people a something tangible that we can start to talk about in these meetings and flesh out as people can kind of contribute. So just needs to be kind of a proposal, throw something out there, and we can kind of collectively collaborate on it and help define it and drive it.
Yeah, and on this topic, we've had a couple of different attempts now to have a taxonomy document of the edge, and so I think this is certainly something that we've been needing to do. So that if folks would like to work on it, it'd be a great thing. I'd love to see this work happen.
Yeah, I'm going to pop this. Yeah, so this is kind of give reference to that as kind of the starting point. And we could kind of take that and then begin to further flesh out these different things. So like this CXL proposal, that maybe fits here and here, maybe not so much there. But there's different things here that may be in common with these other parts as well. But somebody just needs to kind of sit down and do some thinking and just kind of spend, I don't know, maybe 20 minutes, 30 minutes, kind of throw something together that we can kind of present to the team and start to drive some of these things.
Yeah, and like I said, I'm suggesting that we use the mail list for this rather than the monthly call, so that we can iterate much faster on this, and then we could have a topic. The monthly meeting could then kind of have a standing conversation about the document, for instance, every week, or every month. We could have a update on what the document's like, the changes that have been made, those kinds of things. Be a great use of our monthly calls.
Yeah, I could I started to flesh this out. I could send it on the mail list, and we can kind of start a thread, and people can kind of contribute there, and then we can kind of just touch base when we have the monthly calls.
Does Open Compute have any Slack or Discord workspace?
I'm not aware, but there's no reason that we couldn't create our own for our work group together. You know what I mean?
What I find is because a lot of times, especially at the early stage, at least for me, this is more of a learning process. So put it in the permanent email forum is not one of my preference. So if there is like a Slack or Discord workspace, it'd be a lot easier to share ideas and what need to be added to the document.
Well, why don't you work with John and we'll create one. We can create a Slack channel. I don't think that won't be an issue. The foundation, I'm sure, won't mind, and we can ask for their assistance as well.
That'd be great.
In time gone by, we have had other forums rather than the mail list for different discussions. We used IRC channel, those kind of things back, many moons ago, before Slack was a thing. But we certainly had online, IRC channels and stuff for each other to communicate more quickly.
Yeah, we could do something like Etherpad, but that's just pretty much text. If we wanted to share kind of I just started putting this on a slide. Maybe we flesh out these things in an Etherpad, and just somebody then just takes it and drops it into a slide. But we could collaborate on the Etherpad and then just start editing that text, because that's really what we want to do. Yeah, so maybe I could start an Etherpad with these different headings, and we can start to just kind of capture the information. What do you guys think about that? So here I'm talking about this. Let's see. Let me see if I can share this. Well, here I'll drop the link in the chat. You guys can look at it. Where's the chat? So this gives you kind of a way to share kind of like pages of document text, and then everybody can kind of edit it. I'll tell you what. I'll take that action item, and I'll mail out just this little thing I started here, and then maybe I'll set up an Etherpad and we can give that a try, or if someone wants to suggest something else, and then I'll reach out to the foundation and see, if they have any thoughts on setting up a Slack channel or something. Does that work?
Yes, Slack channels will be my favorite. It's free, as long as you don't care about the history.
Yeah. Yeah, I'll just run it by the foundation just to make sure that they're okay with that it would fit in with the sharing guidelines and everything of the foundation. And I don't foresee a problem, but just need to run it by them, I think. All right, good. Well, okay, I'll take the action item to start this, and then if you guys want to contribute to it, that would be great. And then if somebody wants to kind of take over, I'll share that PowerPoint slide I just started. If somebody would want to kind of maybe take over the editorship of that, then it's just a matter of kind of taking what we all agree on the Etherpad and dropping it into a slide. Does that make sense?
Yeah.
Sounds good to me.
Okay, fantastic. All right, so is there anything else we want to kind of let's kind of then table that topic, because we'll work on that on the email threads and we get this Etherpad set up. Does anybody have any feedback on the regional summit? I'm guessing no. Okay. What do you foresee with this CXL proposal? Like, could we start to build some type of I think, Craig, you kind of hit on these three types, and at least when you were reading it off to me, that sounded like each of those three could fall into some
CXL,
some aspect of what we do.
Yeah, CXL is an OCP project as well, right? So that's discussed in a project. Yep. I mean, it has its own, CXL has its own group, but it's also being incorporated into OCP. So I was just kind of talking about the general, if you go to what is CXL, kind of a document from the CXL Foundation, it'll have, the different types and how CXL works. I mean, it's basically considered an alternative PCIe layer. So it uses PCIe physical signaling and then is an alternative payload over PCIe. And so what it provides is coherent access to memory space so that each of the devices in the CXL domain are able to share memory locations and then also have a coherency to that sharing of memory address locations. I mean, maybe.
So I was going to say, so how do you see, what we could do on the edge, from the edge side to, maybe contribute to that work, or could you just take that work verbatim and drop it in? Would there be additional requirements that we would need to?
I mean, I think it would be a use
consider?
case of how you wanted to use, say, the memory or the or how you wanted to use the accesses to the accelerator or to a network interface, those kinds of things.
So really, this would be kind of more, also kind of a use case
Yeah, I mean,
exploration.
everything, right? It's like basically we have all of these open systems, right? That we incorporate and end up creating, open hardware that incorporates those, right? So the OCP doesn't define PCIe, for instance. We just specify, oh, this device should include PCIe Gen 3, Gen 4, Gen 5, Gen 6, whatever, right? But we don't define necessarily PCI, or we do not define PCIe, right? We use PCIe.
Right.
The same way we would be a consumer of CXL, not necessarily, the OCP would
Changing
drive that. If you were interested in changes to CXL, a new packet format or a new capability, that would be something you would take up with the CXL, not with OCP, right? But the uses of that is something that is, how would you apply that to open hardware? And a lot of these things, it's basically you want to have a specification in OCP because of the open source nature of our specifications. Allow other people then to make derivative works and to combine those. So the more pieces and parts that we contribute, the more that other people can build upon, right?
Yep.
I mean, it may not even be us that use it. It could be another group that says, oh, well, we're going to pick up this piece from this OCP specification that the Edge group did, and we're going to extend it in a certain way or whatever, right? And then that, I mean, just think open source software, but as you apply it to hardware, I mean, it's a slightly different.
Yeah.
The tooling a lot of times for open source hardware is different. You don't have a tool chain that is another set of software, but in order to make a chassis, we'll provide you with a step file that can be fed into a metalworking machine that can create that component from an open source file, but it requires a tool chain that's actually a physical machine, right?
Right.
But you want those to be open rather than, say, a proprietary way of doing it, which, it's okay, but it may not be interoperable, or it may not be able to be extended and changed in that case.
So in the when you listed kind of the three types there, so I'm thinking that each of those could have use cases that we could contribute. For each so maybe that's where we could start to drive some use case specifications. Would that make sense?
Yeah, hang on just a second. Let's see if I can't find So here, I'll post this copy. Where's my Zoom again now? Sorry. Chat. Okay, so for instance, this is a presentation on CXL 3.1, and it has an associated webinar that's on YouTube. But that those types of documents are what I'm talking about. Why don't you open that one up, John? So
yeah, hang on, I'm going to try to share here.
Share,
Let's see.
yeah.
There, can you guys see that?
Yeah. Yeah, just keep going to the so basically, this is the scope of CXL. So showing you what CXL 1.1, which is that little small processor interconnect, and then that's led to CXL 2, and now to CXL 3. And this is kind of the composition part that I was talking about, right? So then keep scrolling now, and I'm sure they'll now tell you about the different. So this is the usages, right? So the one on the left is the type 1, and then type 2, and then type 3. So, and see up at the top, see it says right there, type 1, type 2, type 3. So a caching device and accelerator, which is like a network interface or a NIC, right? And then accelerator with memory is a GPU. And then the memory type 3 is for memory buffers and memory expansion. And so that was CXL 1.0 and 1.1. That's like the beginning, the foundation, if you will.
Yep. Okay, let's put that in there. When I do that, do you guys is it still showing that window, or is it getting blocked?
Yeah, no, we see it. All
Okay.
I see is the slide.
Okay.
And maybe I don't know, a web browser.
Yeah, I was editing something. I was just wondering if
Yeah,
because
no
it blocks on my screen. I was hoping it wasn't blocking for you guys. Okay. All right.
So I don't think we have to go through this here, but this is kind of a reference to kind of catch you up to where the CXL is now, right, with the version 3, and actually 3.1, which really has some pretty interesting things. So you have like not only pooled memory, meaning you could have multiple memory cards and have multiple processors share that in a pooled fashion, and you can then take over half of a card, half of a card, half of the next card could be your pool, and then another CPU could have a piece of that, etc. But now they're actually 3.1 will allow multiple CPUs to share a CXL memory card and to have shared access to that. So you have a shared memory between two different processors for workloads that need a shared memory environment. And the interesting thing here, though, is right, because this is based on PCIe, what we're talking about is PCIe cards plugging together, essentially, right? So it uses the PCIe physical layer.
But it has a different physical
We have the different packet
realization.
format essentially.
Yeah.
Right. So I mean, it would be the same as saying, hey, I've got an Ethernet card and I'm using Ethernet packets to transfer data, and then I've got IP, and then on top of IP, I have UDP and TCP. And so this would be, use PCIe, and now it uses CXL, and CXL can have low latency and bulk transfer, and they can intermix with each other. And you can have things then happen so that two PCIe cards that have their own memory can then transfer direct to card without involving the host CPU. So kind of like a bus mastering, if you will.
Right.
But then you can also use the switches to create arbitrary topology. So you can have a leaf and spine, you can have a switch, you can have a flat switch, a leaf and spine, a toroidal mesh. You can make any kind of network topology that you would like. Oh, I see that it's on that one right there. Supports tree, mesh, ring, star, butterfly, multi-dimension.
Oh, where do you see that? Oh yeah, there's okay. Yep.
And what you're talking about though, instead of like IP addresses in PCIe, you're talking about physical memory space or memory locations that the CPU would be referring to. And so you have essentially a translation engine that says, this memory address range on this card maps to a memory address range in your memory space, Mr. CPU. So when the CPU refers to that memory address, then the PCIe will know, oh, that he's talking about a PCIe card that's down here mapped into his memory space.
Yep.
Actually, this is actually a very good example of CXL, the diagram that shows the three usages. Because
So
it's
1, 2, and 3. Yes.
Yeah. Because I mean, a lot of this benefit anywhere, right? In the main data center as well. However, those extremely useful for edge. Like use case one, Nick. I assume that will speed up the network. It will provide more network caching, I suppose. And so for remote locations, network availability could be a problem, right? The latency and then throughput, and that could help that. So usage two, obviously, having a small, very space constrained location, having a dense computation will help. That's type two. And then type three for memory buffer, of course, there's not much storage either in memory. So all three use cases apply to the edge use cases. It just need more. It needs even more than already available.
Right. Well, those are just examples too, right? I mean, of those, because basically the type 1, 2, and 3 really refer to type 1 doesn't have RAM on the board. It only has, a ROM address or some memory that it's using, say a packet buffer, but no DDR memory. Type 2 then has that buffer, but also has its own DDR memory that you want to be able to access from the host CPU directly. And then obviously the memory is really all about having DRAM accessible and not any other interface types of IO, right? And so then that type 2 could be used for certain smart NICs actually have onboard memory, and so there's actually Ethernet switch or Ethernet interfaces that are both the type 1 and the type 2, depending. Some of the accelerated Ethernet cards, for instance, will have a coprocessor chip that also has DDR memory, and so it may read the packet in off the Ethernet and then actually have, say, an ARM processor on the board, do some processing, and then write it to DRAM. And then now your host CPU can actually address that memory in that DRAM on that Ethernet card and not actually have to transfer the data over to PCIe. It can actually do the operations on the DRAM that's on that Type 2 card. And then, for instance, it could say maybe it's going out another network interface, and instead of the CPU having to then read all of that data and then write it to the outgoing card, the CPU can then just say, hey, I'd like to make a memory copy from this location to this location, and the PCIe switch would then get involved and actually set up a direct transfer between those two interfaces without it having to involve the CPU. So your CPU can then continue to do processing while the I/O transfer is actually occurring between two, say, network cards.
Just said if it can be, even if I already seen presentation on CXL, what you just mentioned, memory there or not, those are very useful information. Even CXL is not defined by Open Compute, but it's still the hardware domain, right? So the application, even the operating system infrastructure folks are not familiar with. So if those can be documented in this group, I'm sure it will be very useful to the infrastructure app users to leverage.
And actually, let's see, OCP CXL. So
there are some CXL presentations I know, but it's not like really edge, like all combined into like this is all the hardware technology for edge. I think this is where this group could really help.
Yes. So let's see. So this is a presentation from the Global Summit in 2022.
Are you sure? Do you want to share that, Craig?
No, hang on. I'll let you. I'll just post it to the chat if that's all right.
Oh, okay.
Let's see. Where'd my chat window go? Oh, there it is.
Yeah, that's the problem.
Try that one. That's
let's see. Yep. Okay. Hang on. Now I gotta share that. Can you see that now?
yeah.
So from the edge perspective, then what we're kind of saying is we could maybe build on what was done for just OCP in general and kind of apply this to edge scenarios. Was that the thinking?
Exactly. I mean, they're already, CXL is more tightly integrated with OCP. The CXL consortia is using OCP, is my understanding, for their governance.
Yeah.
But so OCP is CXL conversant, if you will. You know what I mean? It's not like this is some process of us trying to explain to other parts of OCP what CXL is. So this is from the server group, for instance. This presentation was in the server group, and the Semiac was the IC lead for the server group that was the presenter of this.
Yes, I'm kind of thinking like what could be done is take those two things, right? Take this and that, and then if somebody could create something to kind of map this to our edge scenarios, is that
Right.
what we're thinking?
Yeah. I mean, exactly.
Yeah.
The idea is for us to create use cases and requirements so that folks that make hardware would know, oh, the edge group would like to have CXL enabled in our systems. Because, if you go back to that first presentation, the CXL presentation, right? Yeah, go to the very top of that one again, maybe the second or third. There. Whoops. Yep. So this one right there. So these guys are actually on the board of directors of CXL. So you have a combination of, software folks, Alibaba, Google, Meta, along with hardware folks, ARM, AMD, NVIDIA, Samsung, and then integrators, Rambus, Dell, HP, right? So basically you have, it's a similar type situation that we're in, right? And so we're wanting to use, we want Dell and HP, among others, obviously, right? But you want them to create stuff that work on, operating systems from Microsoft or cloud systems from Google or Meta, right? That use Rambus. Rambus is an IO company that works with CPU. But then if you'll scroll down a minute, there's 255 member companies, right? So there's more. I think the next slide has the, well, never mind. I thought they usually have a bigger slide of like, these are the board of director companies, but there's, a lot of companies involved in CXL. So we just want to be able to say, hey, here's a use case when you're doing this, remember us edge guys that want to use this for edge cases, not necessarily data centers, not necessarily, big servers, but small things, IoT devices even, I think.
So Victor, what was your kind of impetus, or what got you interested in wanting to talk about this?
To be honest, I'm independent. I'm just interested in a lot of things. I was a database consultant too, was my career for the past 20 plus years. But I've been just joined open source community in the last almost less than 2 years, but really loved it. Because I'm an independent, so whenever I don't have a database contract to work on, I go to different communities and learn. So I learned a lot about the software stack. And then finding more and more that to solve a problem, you have to know the full stack. That's why I'm interested in, just finding, really talking to smart people. Like, for hardware, you guys are the experts, and really just love to talk to smart people and learn what the problem is and the possible solutions.
Fantastic. Yeah, because I actually drove kind of some of the things, and we're kind of running up on our time here, but I can just jump back to share that. Let's see. So that's what kind of drove
that I can do forever. Sorry.
This DCMHS topic. So we had some folks wanting to be able to drop in different CPUs, but into sort of the same environment, right? So you basically just like swap out the CPU without having to build a whole new server just for each specific CPU variant. And so that's, that kind of drove this interest in DCMHS, and we're trying to get that off the ground. And I kind of see that we could maybe even do the same thing with this CXL card, is get them to present, but the data center guys are thinking, maybe even that whole presentation that you just had. That's probably, maybe that's even up on the summit. We can basically point people to that.
Well, yeah, if you're interested in CXL or CXL and OCP, there's plenty of YouTube videos of conferences, presentations, webinars,
Yeah.
both from member companies as well as from the organizations themselves, and then obviously from, the Global Summit. All the presentations for the Global Summits are available on YouTube in the OCP channel.
Awesome.
And probably even this call.
Yeah. All right. Well, I think we're kind of at our time here. I appreciate everybody's input. This is actually a pretty good session today. I'll take the action item to send out that slide that I started working on. I'll kind of let the group know in an email that maybe we'll start an Etherpad to start trying to just take the LF work and maybe start to turn this into a contribution. That we can bring through the Edge team, and then I don't know about you guys, but I kind of see this CXL then could also maybe be an extension to that. Once we kind of look at all these different high level Edge use cases, build in maybe also kind of the use cases for the CXL technologies into the Edge. Thoughts? Okay.
CXL, but one other area I just got to think of, because in the open compute ecosystem, there's a discussion about a software hybrid co-design for AI workload. But the same thing applies to anything pretty much, right? So what is the software hybrid co-design for edge use cases? I know it's including AI, but what's different? What need to happen to the hardware for edge use cases, starting from obviously the chip itself all the way to, I guess, everything.
Well, so have you looked at many of our documents by any chance? The Open Edge?
I look at before, but a lot of good document. To be
So-
honest, too
Yeah.
long.
Well, so in the Open Edge, in our document space, there is some use cases, because primarily we were interested in wireless communication. So there's different white papers that discuss using an Edge application to create a cloud radio access network, and how you would use these servers to do that, and what the difference is, how that it differs from the standard way of doing that. So those might be things for you to look at to get some idea about use cases and white papers on technologies that we've done in this group before our scope was expanded. Like I said, we were focused primarily on a particular server called the Open Edge server, and that has a primary use case of the base of the tower, or actually it can be farther away from the base of the tower, even in the regional networks and the taxonomy that you showed. But that might be a starting point for you to get some understanding that of the edge group work, but then also in the telco, telco was actually everything, including the edge, and we did have several types of CPE gear which would fall into those. Not the IoT, but the other edge servers that you spoke of, or that the Linux Foundation taxonomy showed. So we have the telco group has several CPE devices, even down to what you would consider to be like you may call it your home gateway or your NIC, your router gateway at your house. So we actually, the telco group actually has specifications for those, and then also for what would be used at, say, a business location for their access, and also retail location. So there's several different sizes of servers that are defined in specifications in the telco group.
I read one article about designing hardware for digital twin, which didn't give a lot of details. I wonder, was that covered? Or in order to support digital twin?
Yeah, this is it. The telco group started in 2015, and AI, digital twins, those kind of concepts. Industrial Revolution 4.0, that kind of thing didn't come around for quite some time. These were things that service providers, say AT&T, for instance, would use to give to their business customers or to their home users for their services. Right? I don't think things for applications such as digital twin are actually there.
Yeah, that would be I guess another topic I'm interested in too. If to support digital twin, what needs to happen to hardware side? I guess that's the question.
Okay. Yeah, I mean, we should have another session on this or something, and discuss it further on another call. I'm gonna have to.
Yeah,
drop.
Yeah, I can add this if we want to keep talking about this. I can add this next month. Because next month I think we're going to get the DCMHS was going to be in the telco group. So if we want to kind of continue this, we can put it on the agenda for next month. I think this gives everybody a chance to kind of look at some things, and we can have continue the conversation then.
It may be July though. If you have Dirk coming on this June.
He's coming. Well, he's coming from he's on the telco.
Oh, on telco, not on the not on the edge call. Okay, cool.
Yeah.
Okay, never mind.
Yep.
Appreciate the.
Okay, guys. Well, I know we're over our hour, but I appreciate everybody's input, and look forward to talking with everybody next month. And with that, I'll talk to you all later.
Sounds good. Thanks. Bye.
All right. Bye-bye.
Hello.